Yeah, so in this module, we are going to be talking about time. So, time is something which we are going to be needing. Like, even if you talk about the real life, how do you actually use time? So, like, let us say you want to talk about this class. So, you will be asking for how long this class is going to be there. What is the duration of this class? Correct? Similarly, if you talk about movie, you are going to be asking how long this movie is going to be there. What is the duration of this movie? Similarly, like, if you will see, we are having like, this classroom or any movie or any other scenario. So overall, like, in corresponding to time, you are going to be asking about the duration. So when you talk about time, so what is time? So time is a measure to like, time is a way to measure the duration of events. So if you are having lots of events, with the help of time, you are going to be measuring that how long that is going to be there. Also, you will be using time so that you can express in which order it is going to be there. Like, let us say I say at 8 p.m. I am going to be starting the class. At 8:30 I am going to be taking the doubts. At 8:45 I am going to be solving a question. So if you will see what I am actually doing, I am putting all the order. I am actually saying that at what time I am going to be doing what. So what I am basically doing, I am putting all of these events in some order, and I am telling that in this order I am going to be taking care of that. So, like, when you talk about time, so basically here what we do, we try to understand the sequence or the order of the events. Now, if you talk about time, so how we are measuring time in the real life. So we are making use of something called as physical clocks. So in their physical clocks, like right now also, if you will see, the time is 7:11 here, right, on the top of the iPad screen. So how I got to know about it? By looking at the physical clock. So we measure time by using physical clocks. This physical clock is going to be keeping the things consistent. What does it mean by that? So if this is me sitting here and this is my other friends living in the same society, or you talk about living in the same city, I'm not talking about the same like, country even, because in some of the countries I have seen within the same country we follow a different time zone. But yes, if we talk about India, if this is me, if this is my relative, or this is my friend, or if this is my student, like if we all are there in the country India, if you will see, there everyone is going to be following that standard clock only. If I am saying I am going to be starting the class at 8 p.m., so every one of you, like whenever the clock, the physical clock for all of you is going to have 8 p.m., you all will understand that this is the time when we are going to be starting the class. So this is the thing which is like, this is the thing which everybody is following here. Now, in order to keep everything like, a proper order, like, for an effective communication, we will be needing that all the clocks are synchronized. Like I have seen at home, like, if I'll talk about, like, some people, like what people do, like even in my living room we are having a clock, and that clock, like if my room's clock is showing 8 p.m., my room's clock will show 8 5 p.m. And why Indians usually do it that way, like I'm talking about basically my home, why we do it that way? They believe that we are going to step outside the home from the living room. So if this clock is 5 minutes ahead, so that is how we all are going to be ready before time. So that is the basic psychology which we guys are following at home. But is this a correct way? Like, can you have an effective communication that way? Like, this person, like, if somebody in my living room is sitting and if the time is 8 5 p.m., and if somebody sitting in my room, the time is 8 p.m., but this person will go and complain that class was supposed to be started at 8. Right now it is 8 5. We haven't started the class yet. So this guy is going to be disappointed because he is following a clock, even though it is a physical clock, even though that is the clock everybody is following, but this guy's time is showing something else. So is that which is going to work correctly? No. In order to have the effective communication, it is very important that all the clocks are synchronized, because that way it is going to be easier for us to compare the order of the events accurately. And because of this thing, if you will see, like, I'm talking about the old era, that particular time, even in the mobile phones, we used to set the time manually. But now if you will see, we have something like automatic date and time. So because of that, what will happen, you just have to select that time zone. Like for India, the plus 5:30 is your time zone, where what is actually going to happen, if this is something you have selected, so by default it is going to be synchronizing the time, like it is, the time is going to be same across all the devices. So if you have selected this time zone in your phone, if you have any other person in the same country, if they have also selected it, so they all are going to be seeing the same time. And why we all will be doing that, so that we can avoid the confusion. Previously when people were setting the time manually, so in that case this issue was something which was very common, because they all were setting it manually. So there was a lag of 1 or 2 minutes, like +1 or -1. But with this time zone, all those issues got resolved. So if you talk about it in the real life, like, we are using physical clock, and how these physical clocks are going to be working. So we have something called as latitude and longitude. So we use your physical clocks based upon the latitudes and longitudes, because there is no single global standard clock. So while each country may follow the same time zone within its border, the entire world does not have a global clock. So if you talk about India, so here what we follow something called as IEST, which stands for Indian Standard Time. If you talk about US, what do we follow here? Like, in certain places we follow EST, in certain places we follow PST, based upon the region here. So when you talk about it, so this is your Eastern Standard Time, and this is your Pacific Standard Time. So based upon, like, what you have selected, like let us say you have selected PST here, like for the better clarity. So like let us say we are talking about India. So if it is 8:45 p.m. IST in India, so it is around, like the same time is going to be around 8:15 a.m. PST. Like in the US, the same time is going to be reflected like that. What does this mean? This means there is going to be a difference of 12.5 hours. If you talk about EST here, so in this EST, there is going to be a difference of 13.5 hours. So even though time zones are different, people can still coordinate across them. Like otherwise, what will happen? Like I have a class and this person is there in India. This person is there in UK. This person is there in US. This person is there in Germany. So if you will see, I have a like, and this is me. I am sitting in India. So if you talk about this example, so I am sitting here and I am taking a class, and I have a people who are in the different time zones. Still, they all will coordinate and they all will join the class on time. Yeah, so for this class, like, even though we have different time zones, people can still coordinate across them. So if I have to start the class at 8:30 p.m. IST, so this is the time which I have specified. That is why when you have to talk about the global time zone, so if you have to talk about the global time, we generally talk about it by providing the time zone. Like, we will be telling that, okay, if I talk about 8:30 p.m., so I'm going to be following the Indian Standard Time here. And what is exactly going to happen? These guys who all are sitting in the different parts of the world, they can still coordinate. If I have to start the class at 8:30 p.m., so what will happen if we have the student who is joining from UK? What he will do? He is going to be converting that time to their local time. And how? By adjusting the time difference. So why, like, how it is actually helpful, because this is going to help us with the effective communication, and we can collaborate with each other across the different time zones. When you talk about the same thing in the work life, so there we will be having different teammates sitting in the different parts of the world. Now if we want to coordinate with all of them, How we will be able to do that? We are going to collaborate with them based upon the different time zones. Like if I want to talk to a guy who is sitting in, let us say, US. So if it is my afternoon time, it's not possible for me to talk to him around the same time. So what we can do, we can talk about a time which is going to be working for both of us. Either it is going to be in my morning or it is going to be there in my late night. So that is how, so that both person are going to be available for that. So for that effective collaboration, effective communication, this time is actually going to be helping us. So when you talk about the human activities, even for that it is still okay to rely on physical clocks. So like let us say somebody is in India and another person is in US and somebody is there in the UK, they can still sync their times by adding or subtracting the time zone, so that they can make it possible for, like, to have a phone call, if they want to text someone, if they want to video call. So even though they are in the different time locations, they can still collaborate with either each other, they can still talk to each other. So in the real life it is still manageable. Now we are going to be seeing the same in the terms of application. So like, let us say we have a centralized system. So in that, every machine is going to be having a different time. So like let us say these are the different machines which we have here. Okay. Now every machine is going to be having its own local time, which is going to be recording the events. Like let us say we are having certain events like E1, E2, E3. Now every event is assigned a timestamp. So these are the events. We are assigning some timestamps like T1, T2, T3. These are the timestamps. Okay. Now consider that this system could be running in different time zones. This machine could be there in the UK, US, or India. So if all the events are happening within the same time zone, it becomes easier to determine the order because everything is based on the same local context. So that is going to be simplifying the managing and coordinating events. Correct? Because here what we are doing, like even though, like, if we talk about all of these events, even though like if we are in the same time zone, so like let us say I am sending you a message at 8, you are receiving it at 8. So you are going to understand it, okay, this person has sent it to me at 8 and we have to, like, at 8 I'm sending that, okay, in 15 minutes you have to join the class. So because we all are in the same time zone, it is going to be easier to coordinate. Correct? Now, what I will do, like since here I have specified some events, let me also order them. So if I do it something like E1, E2, E3. So basically what I am doing here, I am ordering the events. So I am saying that these events are going to be happen in this order. So I will take care that, okay, if I'll have to execute these events, what is going to be the order for that? Now, let's think about a distributed system. So when you talk about distributed system, what happened? Instead of having one big machine, we are going to be having a machine which, like, where, like, if instead of keeping everything at one place, what we will be doing, we are going to be making use of multiple machines which are clustered together, and here different machines are going to be working together. So for this particular one, like I'll just take that, okay, in this distributed system, what is there? So we are having one machine. So this is our machine M1. This is, let us say, our another machine M2. This is our machine M3. So these are the different time machines. These are the different machines in a distributed system. Now let us say this machine is there in India, this machine is there in UK, this machine is there in US. Now here we are going to be following certain timestamps as well. So here the timestamp 1 is going to be there, here the timestamp 2 will be there, here the timestamp 3 will be there. So that is how I have divided it out. So in this setup, if you will see, every machine is going to be having its local clock, and we are going to be setting that clock to its local time zone. However, no clock is perfect. So no clock is going to be 100% error free. No clock is completely free from accuracies. Each clock has some degree of error or deviation. So just like, when you talk about chemistry lab, where we say that here we will be having some deviation. Similarly, when we will be talking about clocks, so there we are going to be having some inaccuracies. So when we will be comparing our timestamps from different machines over time, we can expect some differences. Like, there could be some difference from, like, in the timestamp from different machines. And that is because there are going to be certain errors. So when humans, like, when you talk about humans, so they might not be able to notice these small differences, but if you talk about it, these are very significant for the machines. So when you are going to be dealing with very small unit of time like nanoseconds, at that particular time, you are actually going to be understanding the difference there. Now we are going to be discussing that what are the challenges which we face with time in the distributed system. So like, let us say that we are having two events, E1 and E2. Now, each event is time stamped according to the local clock of the machine where it is happening. Like, because of the inaccuracies, the timestamps may not align, which is going to cause some confusion about the order of the events. Like, let us say this E1 is happening, like, let us say something like 10. So this is your 10 hours, minutes, seconds, and milliseconds. Okay. And here we have a slight deviation. Let us say when you talk about this event 2, so this is going to be scheduled at, okay. Now, if you will see, we will feel that because after looking at this timestamp that, okay, timestamp 2 is going to be like, occurring after the event 1. Why? Because this has this timestamp. So first this will happen and after that this is going to be happening. So that is how it is going to be understood. But the actual timing could have been affected by the clock drift, which means the events may not have happened in the same exact order. So this lack of synchronization is a challenge in the distributed system. So when you talk about the application where order of events are going to be very important. So in that case, this challenge is going to, this lack of synchronization is going to become a challenge. So let's talk about banking system. So if transactions are processed out of order due to some time issue, so it can lead to significant errors, right? Because when you talk about banking system, you need everything very accurate. So if you like, so what you can actually do, you can ensure that all the machines in a distributed system have consistent and accurate time so that we can maintain the correct time overall, so that we can ensure that the entire system is going to work correctly, right? So if you talk about a distributed system where you want to know which event has happened first, your event 1 or event 2. So you might think that you can just compare the timestamps and then you can determine which will happen first. Like, if you talk about this scenario, so what you can do, you can just compare this timestamp with this and accordingly you can say event 1 will happen first. But if you will see, this is not going to work correctly. This approach can have some issues. What it could be. So firstly, you need to remember that each machine has its own local clock and no clock is perfectly accurate. There is always going to be some error or deviations in the clock. So if events are on the different machine, the timestamps might not be 100% reliable. Second of all, the information about event 2 might have to travel across a network so that it can reach to the another machine M2. So this is going to even introduce something which we call as network latency. What does it mean? It means the time it is going to take for the event information to send from one machine to the another one, which is going to be adding another layer of uncertainty on the exact timing. So if you try to rely on physical clock to determine which event happened first, you might not get an accurate answer. The clock inaccuracies and network delays can make it impossible to pinpoint the true order of the events. Now, what is the problem with the physical clock in the distributed system? Okay, so in the real world, physical clocks are great for measuring time, but they do not work well in the distributed system. The problem arises because clocks are there in the different machines which are not perfectly synchronized, and you will be having some events which will depend on the network communication, which is going to be adding more delays. Now let us say that we have a WhatsApp group. Okay, in that WhatsApp group we have people from different parts of the world. So like let us say here this person is there from UK, here this person is there from India, here this person is there from US. So that is how we are having people from the different countries. Let us say they all are playing a game in the group, and it matters who is going to be answering first. Now it will become a challenge for WhatsApp to figure out who sent their message first, since each person is there in a different time zone and their messages have different timestamps based on their local clocks. So if you will rely on a physical clock, the digital timestamp, you won't be able to determine the exact order of the messages because your clocks are not synchronized. For distributed system, especially when determining the order of the events across different machines in different time zones, in that case, your physical clocks are not going to be reliable. You cannot depend on the timestamp alone to accurately figure out which event has happened first because of the clock inaccuracies and the network delays. Instead, if you talk about the other methods, like what is the other methods here, you can make use of something called as logical clocks. Okay, or some people also call it as vector clocks. So if you are going to be making these things, in that case you can address these challenges. Now we are going to be discussing what is this logical clock. So, what is the solution of the problem which we had in our physical clocks on a distributed system? So, the answer for that is stop using physical clocks and you start using something which we call as logical clocks. Now, why do we actually need logical clocks? So, when you talk about a distributed system, there logical clocks are used to determine the relative order of the events without depending on the synchronized physical timestamp. Whereas if you talk about the physical clocks, they can be inaccurate and they may not be synchronized across the different machines. So logical clocks are going to be providing you a way with the help of which you can go ahead and track the events based upon the sequence in which they are occurring. So this will allow you so that you can maintain a consistent order of events even in a system where clocks can actually differ. They can vary across the different machines. And here we are going to be taking the example of something which we call as Lamport logical clock. So here we are going to be discussing something called as Lamport logical clock. So, this concept of logical clock was introduced by Leslie Lamport. So, what happens in the Lamport logical clock? So, when you talk about a distributed system where you are going to be having different machines, let us say we are taking three machines, M1, M2, M3. Now, all of these machines are going to be keeping track of events and how they are going to be doing that using some local counter. So with the help of this local counter, they are going to be seeing how these events are actually happening. Okay. So let us say we are visualizing it like this: M1, M2, M3. Okay. So this is the timeline for all of these machines. So in this system, if you will say that, let us say at this timestamp T1, event 1 has occurred. If you talk about this timestamp TS2, another event E2 has happened. Now, let us say that here at E3, we are trying to have some send event. Now, what is that send event? Let's discuss about the events. So, when you talk about such a system, here we are going to be having events which will be something like local event, send event, receive event. So these are the three different events which we are going to be having here. Now, first of all, let us see what is your local event. So in local event, here, like whatever the events we are going to be having, they are going to be occurring on the machine itself. So here we are going to be having a process, let us say that process is actually starting or that task is finishing. So all of those are going to be happening here. So each machine is going to be keeping a local counter that will get incremented each time a local event happened. So like let us say this event 1 is starting a process 1. This event 2 is starting another process. Okay, that is how it is happening. Now the second one which we have is the send event. So send events are those events which will happen when a machine is trying to send a message to the another one. So let us say here at E3 event, we are sending a message from M1 to M2. So when machine sends a message from one machine to the another, it will be triggering a send event. Before sending the message, the sending machine increments its local counter and attaches the value of its counter as the timestamp to the message. So what will happen here, if you will see, we are actually taking care of something called as TS1. So what we are doing, before triggering that event, we are incrementing it. And later on, we are going to be attaching the value of this counter with the message. And why that is going to be helping us? So with the help of this timestamp, we are going to be telling the receiver that in which order these events are going to be happening. The next event which we have here is the receive event. So when a message is going to be received by the another machine, the machine is going to be triggering a receive event. This will be comparing the timestamp from the received message with its local counter. Later on, this local counter is going to be updated. Like, how it will be like if we talk about the local counter. So here what we are going to be doing, we are going to be taking max. The max of whatever your local counter is there and when you have received the timestamp. So you're going to be taking both of them, whatever the maximum is there out of that, you are going to pick that value and you will increment it by 1. So this is going to ensure that the local counter is always greater than the timestamp of the received messages, and this is also going to be telling the order in which the events are happening so that we can accurately order all of them. Now we are going to see how Lamport logical clock works. So here what will happen? Every machine in the distributed system is going to maintain a counter, or they are going to maintain a logical clock which will be incremented each time an event is occurring on that machine. If that event is happening, so we are going to be incrementing the counter by 1. When we are going to be sending a message from one machine to the another machine, then the sender machine is going to be including its current logical clock value in the message. We are going to be adding it so that we can understand the order of the events. When the receiving machine is going to get the message, it will be comparing that with its own logical clock with with the one in the message. So whatever if it is going to be receiving some message, so there is going to be some timestamp which you will be getting as a part of that message. You are going to be taking that timestamp and you are going to be comparing it with the one which you have locally. So the receiving message machine is going to be setting the clock on the largest one. This is what we are doing here. So we are going to be taking the larger of the two values and we are going to add 1 to that so that we can make sure that the sequence is correct. Now, what is the main advantage of Lamport logical clock? The main advantage is that it is going to be helping us in ordering the events across multiple machines. So even when physical clocks are not synchronized, but by maintaining a local counter for all of each events and by adjusting the counters based upon the messages exchanged, it will become possible for us to determine that which event has occurred before the another. So even if the events are there on the different machines and even if there are going to be some network delays, still it will be possible for us to determine that which event has occurred first. So if you talk about it, what logical clocks are doing. So logical clocks are providing you a way so that you can go ahead and track the order of events in the distributed system so that you will get to know which event has happened first. Okay. And when you talk about this Lamport logical clock, so these clocks are going to be helping us so that we can go ahead and establish something called as happens before relationship. So what happens, if let us say we are having two events, if we are having event A and event B, and let us say this event A is happening before event B. So then what is expected that the timestamp of, like let us say this has a timestamp TSA and this has a timestamp TSB. So what happens, what is the meaning of that if we are having that happens before relationship here? If we say event A happens before event B, what does it mean? The timestamp of event A is going to be lesser than the timestamp of B. Okay, understood? So if two events which are occurring independently and there is no causal relationship, like here we had this happens before relationship, but if that is not there, if we do not have anything like that, so in that case, none of the event is happening before the another. Then they can have the same timestamp, which is going to be indicating that these are the concurrent events. These are the unrelated events. And they are happening just in the one after the another. Okay. Now let's take some example of the WhatsApp. So there what will happen, if I'm talking about the different people. So if we have a person who is sitting in US, if we have a person who is sitting in India, if we have a person who is sitting in US and they all are there in your WhatsApp group and they all are trying to send a message corresponding to a question. Okay. Like I'll also give some names. So let us say the person sitting here in the US is Alice. The person who is sitting there in US is Bob. And the person who is sitting here in India is Charlie. So these are the different people who are sitting here and they all are playing a game on a WhatsApp group where the event is actually going to be order is actually going to be important. Now, what is happening here, if you will see, let us say Alice is sending her first message. This person is sending it first. So she is incrementing her time clock to 1. After that, Bob is sending. So when Bob is going to send, he is going to increment his logical clock to by 1. So previously it was 1. 1 plus 1, it is going to be 2. Understood? I'm talking about the local events here. Okay. After that, let us say Charlie is sending the message. So the local clock for Charlie is going to set to 3. So these are the different local events which we have here. Now, when you talk about the send event, so when Alice sends her message, she is going to include her logical clock value 1. So this logical value 1 is going to be included in that message. When Bob is going to receive the message from Alice, he is going to check the timestamp. So, the timestamp which he has received from Alice is 1. So he is going to check the timestamp and he is going to update his clock to be greater than 1. So what he will do after receiving this one, he will be doing +1 to it. He is going to update it to 2. Now, when Charlie wants to send a message, when Charlie is going to be receiving a message from Bob, like this is how the flow is there. So when Charlie is receiving, he is going to check the timestamp. So the Bob has a timestamp of 2. So what Charlie will do, he will take the timestamp and update it and update it by 1. So the new logical clock is going to become 3. So by using logical clocks, system are going to be maintaining a consistent understanding about how the events are happening. What is going to be the order of the events. So irrespective what the physical clock is going to be there, irrespective what the network latency, whether we are going to be having some network latency or not, still we are going to be able to understand the order in which the events are happening. So this is very critical when you talk about the applications like your banking system or your messaging system. Here, the sequence of the actions are going to be mattering, right? And why it is like that? Like in a funny example, like let us say they all are talking on a WhatsApp. This person is sending some some message which is funny, but he just sent a part of it. Let us say on the top of that, he sent two message, some message, and on the top of that he wrote something like just kidding, but that just kidding has not received yet. So this, when these two persons are going to just read the first message, they will find it rude. And that is why I'm saying here the ordering is going to be important. Understood? Now we are going to be taking an example where we are going to be using two machines. With the help of that, I'm going to be basically going to be explaining you how we are actually going to be incrementing the counter. Okay. So like let us say we have your machine 1 and we are going to be having your machine 2. So like this is how we are going to be having. Let us say initially we are having a timestamp 0 here, and here also we are having a timestamp of 0. Now, what is actually happening here? Like we are going to be saying that they both are starting with a timestamp of 0. Now, let us say that look, we are having some local events which are happening on your machine 1. Because of that, the timestamp is going to increase. Okay. So what is exactly going to happen? This is some local event which is happening on your machine even. Because of that, your timestamp is going to increase from 0. Now it is going to become 1. Now let us say we are having another event happening here. Because of that, it will be taking your previous timestamp and it will increment it by 1. So your timestamp is going to become 2. After that, let us say now we want to actually have some send event. So which is happening here. So how the timestamp is going to be there? So previously we will be seeing that what the timestamp was, that was 2. Now we are going to be incrementing 1. So your timestamp is going to become 3 here. So that is how it is going to be there. So I hope it must be clear to you how we are doing it for your machine M1. All right. Now we will see for the machine M2. You can see that initially we started with a timestamp of 0. Now at the timestamp 3, your machine 2 is receiving an event from machine 1, which is going to be called as receive event. Okay. So what is exactly going to be happening? So here when it is getting received, so what we are going to call it as, this is going to be your receive event. Okay. Now what is happening, if you are going to see here, at this point your M2 timestamp is going to update. So here we are going to be seeing what the timestamp is going to be there, and how we can do it. I told you how we can evaluate it with the help of a local counter. How it is going to be there? So we are going to be taking maximum of what your latest counter is there, correct? And when you talk about that latest counter, so we are going to be talking about M2. So for your M2, whatever your latest counter is there. And for your M1 as well, we are going to see what is the timestamp which we have received from your M1. And we are going to do +1 on that. So that is how it is going to get calculated. Now if you will see what is your M2's latest counter. So that is your 0, right? So we will say 0. Then the next one is your M1's received timestamp. So what is that? If you will see here at timestamp 3, we are receiving an event. So we are going to do 3 here. Now what is the maximum out of 0 and 3? So that is going to become 3. So 3 plus 1, 4. So if you will see when you talk about your M2, so what is going to be the new logical clock time? That is going to become 4. So that is going to indicate that we have received a message from M1. So now if you will have to perform any on the action on your machine M2, so that is going to be happening at a timestamp 4. That is how it is going to be proceeding. Now using this, we are going to be finding it out. Like, when you talk about some complex way, like, how we are going to be ordering the events which are happening on multiple machines. And these are the events that are going to be happening using the Lamport logical clock. When I want to order the event, how it is actually going to be happening there. So everything that you see, every dot, like, these dots I'm mentioning. So every dots. So what all these dots are doing, so all of these dots are going to be acting as the event. If I want to go and find the relative ordering of the events, I may be making use of the Lamport logical clock. In this case, what we are doing, we are finding out the order of all the events, whatever we can see here. So if anybody will be asking you which event happened, like at the M2, for the first event which happened, like that is going to be happening at the time stamp 4. So if you will see, in the beginning we had, like, for both of the machine we had the timestamp which was starting at the counter 0, but still after that the timestamp got changed. Now let's take one more example so that you can understand this even better. So in this case, I'll be taking 3 machines. Okay, or I'll just span it later. Okay. Now, what is exactly going to happen? Like, all of these machines are starting at a timestamp of 0. Now, like, let us say I want to have a local event for your machine M1. So here that local event is actually going to happen. After that, if you will have to update the timestamp, how it will get calculated. So that is going to be, you have to take the current and you will have to do +1, because here we are having a local, we do not have to worry about any other send or receive event. Okay, so here the timestamp is going to become 1. Now after that, let us say I have another event happening here. Okay, now after this, if I'll have like this, there's again a local event. So if I want to see the timestamp for that, so that is going to be taking the current timestamp for this machine and incrementing it by 1. So this is going to become 2 here. Now after this, like, let us say at this particular time only, we are also be like, there are also going to be having some other events. Like, let us say here when we are at timestamp, like, at this point, what exactly happened? We had one local event at machine M3. So here that event is going to happen, and because of that your timestamp is now going to become 1. Okay. Now after this, like let us say this machine M3, this wants to send an event to your machine M2. This is your send event. So how you are going to be calculating it out? So let us see how we are going to be evaluating the timestamp for this. So that is actually be going like maximum of like your M3, your local timestamp, and you are going to be seeing the M2 timestamp, and on that you are going to do +1. So if you will see what is the timestamp of your machine M3, that is 1 here, right? And if you will see for the machine M2, we haven't had any other timestamp so far, so that is going to be 0. Now what is the maximum out of 1 and 0? That is going to be 1. So 1 plus 1 is going to be 2. So the timestamp which we will have here is going to be 2. So I hope this must be clear to you how the timestamp is updated here. Now after this, like let us say this machine M1 is sending an event here. So this is again a send event here. And I want to calculate what is going to be the timestamp of this particular event. So how it will be calculated? Let me mention it like T dash, this will be T double dash. So this is the calculation for your T dash. Now we will see for T double dash. So that is going to be the maximum since it is coming from M1. So we will be seeing it for M2 and we are going to be seeing the M1. So if you will see what is the maximum timestamp of M1, that is 2 here. And what is the maximum timestamp of M2? That is also 2. Since both values are same, it doesn't matter. So the maximum timestamp which we are going to be getting here is going to be 4. So here, 3. So here we are going to be having a timestamp of 4. So here if you will see both of the values are 2. So out of that, even if we are going to be taking maximum, that is going to be 2. So 2 plus 1 is 3. So that is how you can see the timestamp here is going to be of 3 value. Okay. Now let us say we are having some local event happening here. Let me actually mark it with some other color. These are the local events. Now for this local event, if I want to calculate the timestamp, how I can do? That is going to be taking the previous timestamp. On the top of that, I'm going to be incrementing it by 1. So this is going to become 4. Previously it was 3. So 3 plus 1 is 4. Now let us say that this machine M2 is sending an event to your machine M1. So now we are going to be seeing that what is going to be the timestamp of this particular event. So how it is going to be there? T triple dash. So that is going to be taking the timestamp of your machine M1 and timestamp of your machine M2. So here if you will see when we are sending it from the machine M2, the timestamp is 4. And if you will see the timestamp for M2 is 2. Correct? After that, we do not have any other value, right? So we have 2 and we have a value 4. And what is the maximum out of 2 and 4? That is going to be 4. So the overall we are getting 4 plus 1, that is 5. So if you will see here for this timestamp, the value is going to be 5. So even though the previous timestamp was at 2, like the previous event which happened here was at the timestamp 2, but now the another one is happening at timestamp 5. So you can see with the help of this Lamport, how you are actually able to understand in which order these events are happening. Let us consider one more scenario, like let us say now some local event is happening here. So when we'll have a local event, what we will do, we will take the previous one and add +1 there. So now this will become timestamp of 6. Let us say that now what is happening? Your machine M1 is sending a send event to your machine M3. And now we have to calculate the timestamp here. So how you are going to be evaluating it? So that is going to be maximum of, you will take the timestamp of your machine M1 and for your machine M3. So now what is the maximum timestamp of your machine M1? That is 6. And for your M3, what is the maximum so far? That is 1. After 1, we haven't had any events happening at your machine M3. Now what is the maximum out of 6 and 1? That is going to be 6. So 6 plus 1 is going to be 7. So here you are going to be getting a timestamp of 7. And even if, like, let us say we are going to be putting some of the event names which I haven't had here, but even if you want, you can easily be able to understand how these events are happening, right? You have seen in all of these cases, if I will have to see how we are getting the timestamp, like when this event is receiving here. So like, at the timestamp 6, we are sending event. If you will see the timestamp 6, we are receiving an event. Similarly, at timestamp 1, we are sending an event. At timestamp 2, we are receiving event. At timestamp 2, we were sending. At timestamp 3, we are receiving. At timestamp 4, we are sending. At timestamp 5, we are receiving. So that is how it is happening. So here what I have actually done, I have given a number to all of these events which are happening here. Correct? And how I have done? With the help of logical clocks. And here what we are actually using, your Lamport logical clock. Now using this, I'm pretty sure that here, like, it will be very easy for us to see that which happened before what. And this is what is the basic principle of your Lamport logical clock, where we are actually going to be knowing that which event happened when. So here, if you will see at any moment, if we are having, like, any of the event, so you can actually see how you are going to be ordering them out. And based upon this, you will have the understanding that in future, if we are making use of the distributed machine, so how you are going to be ordering your events there. All right. So I hope this must be clear to each one of you. So using Lamport logical clock, we can actually establish a happens before relationship between the events. And how? With the help of the timestamps. So if you will be seeing, like, even if I talk about, like, let us say this one, so you can see before this, which event has happened, this one. So it is actually going to be very much clear to you. All right. Now we are going to be discussing what are the problems which we face with the Lamport logical clock. Now, when you talk about Lamport logical clock, so they can identify the casual order of events as long as the timestamps are different. But when you talk about two events which are happening concurrently, and let us say they don't even have any relationship between them, in that particular case, like, I'll be just taking example, like, let us say we are having two machines, M1 and M2. Okay. Now let us say they both want to send message to each other, and at the same time they both are also, like, let us say timestamp 0, and they both are actually aligning to the Lamport logical clock. So it is actually like, if we are not using that, it will be difficult to determine which event has happened first. But like, let us say we are having a chatting application as of now. So what will happen? It can happen that machine M2 is sending a message, then receiving. And at the time of receiving, it can still be sending. So you will be getting to know in which order these events are happening. And but there is one more issue which we face when you talk about the Lamport logical clock, and that is like, if if you talk about this particular case, if at this point, um, yeah, so if you will see, let me just draw it properly. So like, let us say that here at T1 you have received an event. Let us say at the same time I am also having another local event. All right, or at the same time I am sending it back. So like, if you are having two machines and if they are sending a message to each other at the same time, basically before that what was happening, we were sending it after a timestamp, like we were having a timestamp difference of 1, correct? But here, if you will see, if you are going to be sending it at the same time, then it will be difficult for us to determine that which event has happened first. So that is the problem which we have with the Lamport. So if two machines are sending messages at the same time, then it gets difficult to determine which event happened first. Now the solution for this is your vector clocks. Now we will be seeing how these vector clocks are helping us. So, when you talk about vector clocks, so vector clocks are an extension to your Lamport logical clock, and these can help us in solving the issue of concurrency. So, when two or more events are going to be having the same timestamp, in that case, your Lamport logical clock is not at all going to be working. In such a situation, your vector clocks are going to be helping us. So they are going to be maintaining a vector of timestamps, one for each of the process in the system. And this will also allow when we are going to be like, when on a above level, if we want to get the ordering, your Lamport logical clock is a great or solution for that. But if you want even at more finer level, in that case, your vector clocks are going to be helping us in a better way. So each machine in a distributed system is going to be maintaining a vector clock. Here what we are exactly going to be using, like, this vector is something which we also use in Java. So quite similar to that. So here what we are going to do, we are going to be maintaining an array of logical clock. So each of your process is going to be keeping a track of the state of all the processes in that system. So here firstly, firstly what we are going to do, we are going to be performing the initialization. So each machine in the system is going to be maintaining a vector clock of size, which is going to be equal to the total number of machines in the system. So let us say we are having three machines here, M1, M2, M3. Like I said, we are going to be having a array of, we are going to be having an array, and that is going to be equal to the total number of machines. So how many machines we have here? Three. So here we are going to be maintaining an array of size 3. This is how it is going to be there. So initially I have kept value 0. So initially everything is whenever you are going to perform this, so initially everything it is going to be 0 only because the initial timestamp is 0. Now the second, after initializing, like let us say now we are having some local event. So example, your M1 is having some local event. All right. After this, what exactly is going to happen? If you will see, we have this vector here. So what it is going to do, since it is a local event, so for that only it is going to increment the value by 1. So what it will do, it will increment its own position in the vector clock and it will leave rest of the values unchanged. All right. Now let's consider how send events are going to be working here. Now, if one machine wants to send a message, what it will do, let us say your M1 wants to send a message to the, let us say M2. Here, if we are having send event. So what it will be doing, it is going to be here what it will be doing, it is going to be incrementing its own vector clock and it will attach that one with the message. Since your M1 is sending a message to M2, so what it will be doing, your M1 is going to be incrementing this value by 1. We are not going to be touching the remaining values. We are only updating it because M1 is sending a message to M2. Okay. Now, when it is about receiving the values, so what will happen when your M2 is going to be receiving a message, it is going to be comparing the received vector clock with its own, and it is going to update it by taking the element wise maximum of the received vector and its own, and it is also going to be updating that out. So here if I'll have to rephrase it better, so here what is exactly happening, M2 is receiving it from M1. That is how it is happening, right? So if you will see how the M2's clock before receiving, it is all 000, and if you will see how the machine M1's vector clock was there in the message, so that was, if we had some message, so that actually had this timestamp. We have updated it after sending. Before that, this was the timestamp which was there in the message. Now what M2 is going to do, M2 is going to update its vector clock by taking the maximum element wise. So here what we are going to be doing, we are going to see, is this greater or is this greater? Of course that is greater, so we are going to update it by 1. Remaining values we are going to leave as it is. Also, if you will see here, M2 has received an event. So if M2 is receiving an event, so this value is also going to update. So now this one is 2 0 0 and this one is 1 1 0. So that is how it is there. Now we are going to be talking about the concurrent events as well. So if we are having two events and if they are having concurrently, means no event is casually affecting the other, but they are happening at the same time. So in that case, it will be difficult to compare the vector clocks because there will nothing be like less than or greater than. It means that both of the events are going to be having the same or different timestamps at the different positions in their vector clock. All right. Let's take some example, like one more example I'll be taking so that you can understand vector clocks better. So let's take another 3 machines, and initially all the values are 0. Okay. Now what will happen? Initial setup, everything is going to be 000 only. Now let us say your M1 is performing a local event. Now we are going to be talking about the first event. Okay. And I will also be put it something like even. So like let us say firstly we are having a local event even, and that is happening on your machine M1. So what will happen, initially the value was 0 0. Now after the local event, value is going to become 100. Okay. Now let's talk about another event, E2, and this is, let us say, happening on your machine M2. So what is the initial value which we had for your machine M2? That was 000. After local event, what will what it will be doing for its own machine? It is going to increment the value by 1 and it will keep remaining values as it is. Now let us say your event E3 is happening. So what is going to happen in the E3? Like, let us say your machine 1 wants to send an event to M2. So in this one, what is exactly going to happen? So here presently the M1 is 100, right? When it is going to be sending it, what will happen? M1 is performing a send event. So for that, M1 is going to be incrementing its value by 1. So it will become 200. So when we are going to be sending a message with timestamp 200. Okay. Now what will happen? Next event is going to be the receive event. So your M2 is receiving a message from M2. So when it is going to be receiving the value, what will happen? Now we will be seeing what is the M2's clock before receiving the message. So that is 010. All right. Now what will happen? Your M1 clock is also there in the message. So what is the M1's clock? That is 200. This is the one, right? So now M2's clock, after receiving the message, what it will do, it is going to be taking maximum of these two. So what is the maximum between 0 and 2? That is 2. What is the maximum between 1 and 0? 1. And third machine is anyway not yet initialized. So this is how your event 4 is going to be there. Now let us say in your event 5, what we are doing, we are having a local event on your machine M3. So in that case, like previously, the value for M3 was 000. After local event, it is going to become 00 and 1. Now let us say we have another event, E6. So now your M1 is going to be sending a message to M3. So when it is going to be sending, what is your M1's clock right now? It is 200, right? M1 wants to send a message. So M1, when it will be sending message, it will be incrementing its clock. So this will become 300. When we are going to be sending a message, it is going to be including a timestamp with it. So the timestamp is going to be 300. So this timestamp is going to go along with the message. Now we are going to have another event. Let us say your event 7. What is that? Your now machine M3 is receiving a message from M1. So in this case, what is the state your M3 was having initially? So before it was 001. Now what is the timestamp which we had in the message? So that is 300. Now what the clock M3 is going to have after receiving, so that is going to become maximum of these two. So it will be 30 and 1. So that is how it is going to get updated. So these are going to be the final clocks. So now you understood that if we will have to order the vector clocks, how you are going to be doing it. So these vector clocks are going to be helping you out in determining the casual order of the events. So now it must be clear to you, like, how we are going to be ordering our events. And I'll also take one small example so that it will be clear to you which event happened first, like, how you can compare both of the events. So here, if you talk about the event E3, so in this particular scenario, if you are going to see how actually happened at your machine 1. So initially it was 110. After that it became 200. So it must be clear to you how the event is happening here, right? Now, like I'm actually talking about the event E3 and E5 here. So the second event is when we are having a local event. So in this one, your M3 had these values and after that it had 001. So in this case, if I will have to determine which event happened first, so what is going to be there? So if you will see, like, for your event 3, we had a timestamp of 200. And for the event 5, we have a timestamp of 001. Now we need to determine which event has happened first. So if you are going to see, this value is greater than 001 in the first two elements. Why? Because when we are comparing these two. So this is greater if we are comparing these two. Like nothing is greater, but we can still say this one is greater. But if you talk about the last one where we have 0 and 1, in that case, we can see that 1 is greater, right? So we can say that event E3 happened before E5. Why? Because in this case, we are already having the updated values. So if you talk about how this has happened, so this event 3 has happened before E5. So we are having this happened before relationship. Because in this case, like, if you talk about the majority, so in this one, the majority is greater. So that is how it is going to be there. Since in the this one, the first two elements are greater. So we can say E3 has happened before E5. So with the help of vector clocks, we can track the order of the events in the distributed system more accurately. So whenever we have a problem where we have events with the same timestamp, in that case, it is going to be helpful. Like let us say we have a timestamp of, like, one event is having this timestamp, the another one is having this timestamp. And if somebody is going to asking us which happened before, so what we will do, since this one is common between both and this one also is common between both, but in this one we have a clear difference, right? So we can say that if we'll exclude these two, if we are only going to be seeing, so we can say if this is your event, this is your E2, so we can say event 1 happened before E2, right? So whenever we are going to be having events with the same timestamp, this is exactly going to be helpful for us in the distributed time. Now I'll be just taking one example in the distributed time so that it will be easier for you to understand what kind of problems it can create when we talk about time in the distributed system. So like, on one of the website, they had a sale time. Okay. At that particular time, like, we have something like Flipkart Big Billion Day. Similar we have on Amazon as well. So let us say that some website is having a major sales event. So generally, like, if you talk about a regular day, so generally it is going to be having something like 20 to 30 orders per second. So this is the regular day offer. But if you talk about some of the sale time, this number is going to rocket. So instead of 20 to 30, now we are going to be having something like 20,000 to 30,000 orders per second. If we are having this huge difference, if you will see, this is a huge increase from 20 to 20,000, 1,000 times more than the usual order volume. So in that case, what exactly happens? They are going to be preparing their applications so that they can work significantly in the company's sale time, because this week is extremely important for any of the organization. Like I'm specifically talking about the sale time when they are going to be shooting a lot of great discounts throughout. So they know that when we are going to be having this sale, they are going to be expecting a huge number of orders. So at that particular time, it is going to be a challenging period even for the developers of that company. So for the security reasons only, I'm not naming this company. I'm going to be naming it as ABC. And I had a friend XYZ working for this company. So what exactly happened? Like this guy was actually working in the checkout team for this company. So what happened? Like, before the sale, they actually, like, if you guys remember when we were talking about the Amazon checkout service, I told you before the checkout, one thing which they have to check is the availability. So if a product is going to be available, then only we will go ahead and proceed with the checkout. So this friend of mine, he was responsible for managing this process. So in the preparation for this critical week, developers actually stopped the development for some time period. Like if the sale is happening in November, they are going to be stopping their development from July to November. They only focus upon testing and they focus upon how they can optimize their application so that when there will be a huge increase in the order, when the orders are going to be at a large scale, when they will have a massive increase in the order. So in that case, the application should perform fine. So during this sales event, they actually flashed a sale. So there was a TV. So instead of, like, it actually initially had a price of 1,20,000. So what happened in the sale time, they actually wanted to put a sale where they are going to be selling it for 60K. But instead what they did, because of some extreme sale offer going on, they were selling it at 12K. So basically this was a marketing gimmick. So it was something like they only had some 5 pieces in their inventory. They were not having more than 5. And if you will see, like, since every second we are having a lot of orders, so these 5 pieces are going to get sold within fraction of second. So when the sale started at 12 in the night, what happened? Although we only had 5 pieces in the inventory, but in 1.5 seconds, there were 120 orders for that TV. And this issue happened only because of the distributed time. And why it all happened? Due to the synchronization problem in their system. So what exactly happened? They had basically 3 services: your inventory, checkout, and reservation. And these all services are actually located in the different geographical location. And unfortunately, the clocks and all these servers were not synchronized. So initially, when TV was sold, the inventory service should have reduced the count by 1. However, due to 1 second delay in the reservation service, which clocked by because of the clock mismatch, the inventory service count, like the inventory service could not update the count right away. So as a result, while the inventory still showed 5 TVs, the checkout service still continued to sell them. This timing issue led to the accidental sale of 120 TVs instead of just 5. So this incident highlights how crucial synchronization is going to be there in the distributed system, and this also shows what is the importance of managing time effectively. If you will see, 1 second is nothing, like, you don't even realize the value of 1 second. But because of that, although they were planning to sell only 5 TV, like in the sale also they mentioned clearly we are only going to be selling 5 TVs. But you can say because of a delay of 1 second, instead of 5 TVs, they sold out 120 TVs. So that is how the synchronization issue is actually going to be there. So I hope you must be very clear about how crucial your time is going to be there in the distributed system. And that's all we had for the time in the system design. Now in the next module, we are going to be talking about scalability. So till then, happy learning. Bye bye.